The calculator has been prepared for road and road rail vehicles manufacturers. On the road config sheet, the vehicle chassis can be selected from built-in list, or the chassis features can be defined by user. In the other loads table, you can define the upper structure components parameters such as dimensions, weight, and position on the vehicle. They are automatically displayed on the drawing. The calculator continuously recalculates the axles, loads, and total weight of the vehicle. The cell's background remains green as long as loads meet the chassis permissible values, and change to red if loads are exceeded. In the power consumption table, you can see the required power for driving the vehicle at the design speed and road gradient, taking into account the specific pavement type. You can also see the wheel's revolution speed for the selected wheel size. In the travel conditions table, you can define two different conditions. Left column, maximum design speed at the required gradient, which shows you the whole characteristic of the power versus speed on the graph. The right column, interim speed, blue, is to check power consumption at any lower speed and any different gradient. By specifying the vehicle engine power, you can also read its capability to drive up the certain gradient. You can read the max speed that can be achieved for defined power of the motor. Rail config sheet is intended for road rail vehicles builders. You can now define rail drive for the vehicle configuration defined in previous sheets. You can select either a single axle rail drive or double axle bogie for both front and rear drive. The calculator automatically checks whether the entered wheel's diameter comply with permissible load criteria defined by EN 15476 standard for road rail vehicles. You will see the red warning if the wheel diameter is too small for the calculated load. In the travel conditions table, you can define maximum speed for traveling on truck at desired gradient. Rail wheel rolling resistance factor is taken into account. You can also see the wheel's revolution speed for the selected wheel size that will help you to choose appropriate motor for direct drive, or gear and motor for geared drive. At the interim speed column, you can check the power requirement for any intermediate speed and gradient of the track. You will see a red warning if your axle distance is too short for desired driving speed on track. The braking on track sheet is intended to design the vehicle on track braking system. Using the tick boxes, you can select the axles that are braked, and you can define the real braking moment applied to every single axle. In the table below, you can see the maximum braking parameters. Green column, as if every axle was braked up to the steel friction coefficient limit. The right column, blue, shows calculated braking performance for your selection. The blue lines on graphs also shows your real braking performance of distance, speed, and deceleration versus time. The green lines show the theoretically maximum braking performance. The brown horizontal line is the limit acceptable by EN 15476 standard. If your braking system does not meet the EN 15476 standard, the calculator will show this information. The support sheet helps you to calculate loads on stabilizers for vehicles that use them. You can specify positions of the front and rear supports and calculate the resultant loads. This Excel file uses macros, and it will be recognized as blocked by Microsoft Windows after you save it on your drive. You will need to go to File Properties and Thick Unblock. Then the file will be fully working. InBeuro provides consultancy and design services for vehicles builders. We specialize in various types of vehicles, and we can help you to build your new product. You can download the calculation tool from InBeuro website. Do not hesitate to get in touch with us.